Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the limiting reagent and excess reagent, students. In the previous video, I discussed about the limiting reagent and excess reagent. What is limiting reagent and excess reagent? And there I gave one best trick also to find mole calculations. Mole calculations. But in this section, I'm going to discuss about the mass calculation, students. Are you following? Mass calculation. That means suppose A reactant mass given, B reactant mass given, C reactant mass you have to find it, students. Are you following? So mass calculation you have to find. Mole calculations nana. A reactant number of moles given, B reactant number of moles given, C reactant how many moles you have to find it. Okay, that is the mole calculation. This is the mass calculations. So in this reagent, in this section, students, I'm not discussing about the limiting reagent and excess reagent definitions. I'm not going. Only I'm going to discuss about mass calculations, students. Okay, now first of all, what is limiting reagent, excess reagent? Just definitions I will tell you. Okay, now what is limiting reagent, students? The reactant which is completely consumed in the reaction is calling as limiting reagent. The reactant which is not completely consumed in the reaction is nothing but it is the excess reagent, students. Are you following? Now see, students, suppose I am taking excess reagent, limiting reagent nama. So for example, A plus B gives rise to AB nana. It is 1 mole, B also 1 mole. So that means 1 mole of reactant A combined with 1 mole of B produces 1 mole of AB. If suppose 1 mole of reactant A combined with 4 moles of B, okay, 4 moles of B, okay, then see, students, here 1 mole of A reactant combined with only 1 mole of B kada, but here what given? 4 moles of B given. That means 1 mole of A can react with only 1 mole of B. That means here what are the remaining 3 moles are there? Here only 1 mole is consumed. Understanding? It is combined with only 1 mole. Okay, na? Combined with 1 mole. That means remaining 3 moles, na? 3 moles will not react with reactant A. Okay, na? That means 3 moles excess there. Are you understanding? Only 1 mole only react with A reactant. Remaining 3 moles will not react. So that's why it is 3 moles excess, na? So these 3 moles will not react. These 3 moles are excess in the reaction. Clear? So that's why this B is calling as the excess reagent. Are you following? It is the excess reagent. And which one? A is the limiting reagent. Clear this, students? Okay, na? So this is about the limiting and excess reagent. Now see, students, here I am going to calculate this problem. 30 grams of magnesium and 30 grams of oxygen reacted. Calculate the composition of the mixture. What is the limiting reagent? Here two questions asked, students. So first, according to the question, I am going to calculate Nana. See here, magnesium and oxygen reacted. So magnesium oxygen reacted produces magnesium oxide. Okay, so here two oxygens are there. That's why I'm taking here 2 MgO magnesium oxide, 2 Mg here I'm taking. So this is the balanced equation. Understanding, Amma? Now see, students, here according to the equation, 2 magnesium weight how much, Nana? Magnesium weight is 24. 2 magnesiums means how much, Nana? 2 into 24 grams. Clear this one. And O2 is 32 grams. Clear this one. 2 MgO means magnesium how much, students? Magnesium is 24. Oxygen atomic mass is 16. Total how much, Nana? 40. Okay. Magnesium oxide is 40. But here how many moles are there? 2 moles. Na? 2 into 40 is equal to 80 grams. Clear? According to the equation, I wrote only masses. Adhaitama. Understood, Nana? So magnesium mass, oxygen mass, magnesium oxide mass, 3 masses I wrote. Now, according to the question, what given, students? But here I don't know which is the limiting and excess reagent. This completely in magnesium weight given, oxygen weight also given. Okay, now so first I am taking magnesium weight, Nana. So 30 grams of, okay, so 30 grams of magnesium is required. How many grams of oxygen I am going to calculate, students? Are you understanding? See here, This is 48 grams of magnesium requires 32 grams of oxygen to produce 2 moles of MgO. Here, according to the question, magnesium, how many grams given, students? 30 grams now, and oxygen 30 grams given. I am going to calculate oxygen mass. Okay, na? So I'm checking oxygen is like excess reagent or limiting reagent. So that's why I'm taking first magnesium. 30 grams of magnesium you take. You have to find the oxygen mass. Okay, na? So how much, students? X is equal to, now do cross multiplication. Cross multiplication do, nana. Cross multiplication, x into 2 into 24 is equal to 32 into 30, correct? X into 2 into 24 equal to 30 into 32. So x is equal to how much, students? 32 into 30 by 2 into 24, correct, amma? So now how to find it, how to find this value, students? 32 into 30 by 32, 32 into 30 into 30 divided by 2. 2 into 24, 48 na? So divided by 48. How much, students? This is answer is 20 grams. So this value, how much we got? 20 grams. That means 30 grams of magnesium required. How many grams of oxygen, students? 20 grams of oxygen is required. But in the question, how much given, Nana? 20 grams of oxygen is required. But in the question, 30 grams of oxygen reacted given. Here what we got? 20 grams of oxygen. That means here 30 grams of magnesium can react with 20 grams of oxygen. Understanding? 20 grams of oxygen. That means here oxygen given excess. Are you following? So here that means only 20 grams only consumed. Remaining here 30, this is 20. Remaining 10 grams, which one, students? It is excess. Are you following? It is not reactive with the magnesium, students. Okay, 30 grams of magnesium can react with 20 grams of O2. Remaining 10 grams, which one, students? Because oxygen, how much given? 30 grams given. So here how much reactant is left over, students? This one, this is 20 grams of O2 na. This is 20 grams of O2. Here in the question, 30 grams of oxygen given. So that means it is more there. Okay, na? So in the question given, 30 grams given, it is more when compared to this. That's why oxygen is the excess reagent. Are you following? So oxygen is the excess reagent. So that's why here, right? Oxygen is the excess reagent. Okay. Understood, Amma. So oxygen excess reagent means magnesium is which one, students? Oxygen is excess reagent. Okay. Now what about magnesium, students? It is the limiting reagent. This also we should check now, it is limiting reagent or not. Once you have to check it. So once again, this one as it is you have to take. Now I am going to calculate the magnesium. So that's why oxygen I will take 30 grams. Are you understanding? Here Nana, in the question 30 grams of magnesium given, oxygen we calculated. Now I am taking the oxygen, I am going to calculate magnesium, students. Okay, now see, Nana, magnesium going to calculate. So again this step same as it is, I am taking 2 into 24 grams of reactant magnesium requires 32 grams of O2. Clear? That one as it is I am writing, students. See here. 2 into 24 grams of magnesium requires 32 grams of O2, Nana. O2. In the question, 30 grams of oxygen given. Okay, na? So, I am taking 30 grams of oxygen. I am going to calculate magnesium. Clear, Nana? Magnesium I am going to calculate. So, cross multiplication, x into 32 is equal to 2 into 24 into 30. Then x is equal to 2 into 24 into 30 by 32. How much, students, here? 2 into 24 into 32 divided by 2 into 24. 48 into 30. 48 into 30 divided by 32. Clear? How much, students? Answer is 45. That means this is 45 grams of which one, students? 45 grams of magnesium is required. That means 30 grams of O2 is required. How many grams of magnesium? 45 grams of magnesium is required. But in the question, how many grams of magnesium given, Nana? 30 grams of magnesium given. 30 grams of magnesium given. So that means given 30 grams, that is less given. Are you following? It is less when compared to 45 grams. Understanding? So that's why small quantity now. That's why magnesium is the, it is the which one, students? Limiting reagent. Okay, now it is the limiting reagent. Okay, we can find calculated limiting and excess reagent. Now what is the question, students? Calculate the composition of the mixture is asking. So mixture means which one? We have to find the magnesium oxide weight. Are you following? Calculate the composition of the mixture. So magnesium oxide mixture we have to find it, students. Understanding? And also it then composition is nothing but magnesium. It is containing magnesium oxygen. First I am going to calculate the magnesium oxide weight also. Understanding? So we know that limiting reagent only decides the formation of the amount of the product, students. Are you following? So that's why I am taking that which is the limiting reagent here. Magnesium is the limiting reagent, correct? So magnesium is the limiting reagent. So that's why magnesium only decides the amount of the product. So that's why what I am taking here 2 grams magnesium and magnesium oxide. Na? So I am taking magnesium and magnesium oxide. This value and this value I am taking. And here 30 grams of magnesium can produce how many grams of magnesium oxide I am going to calculate. See here, this one as it is I am taking 2 into 24 grams of magnesium can produce 80 grams of MgO. Okay, now 80 grams of MgO, students. Now question is 30 grams of magnesium can produce how many grams of magnesium oxide? How many grams of magnesium oxide? Now see, students, x into 2 into 24 is equal to 80 into 30. Then x is equal to 80 into 30 means 2400 by 24 into 2, 48. Clear? Now how much, Nana? 2400. 2400 divided by 48. 50 answer. How much, Nana? 50. Clear? So this is the mass of the magnesium oxide. 50 grams of magnesium oxide is produced. Understanding, students? 50 grams of magnesium oxide. Are you clear this one? Now see, students, here we calculated the magnesium oxide weight. Okay, now so we calculated magnesium is the limiting reagent and next one oxygen is the excess reagent. Correct? Oxygen is excess reagent. How much excess, students, here? Here two questions I calculated. What is the limiting reagent? Completed. Which is the limiting reagent, students? Which is the limiting reagent? Magnesium is the limiting reagent. Okay, na? And next, calculate the composition of the mixture is asking. So in the composition of the mixture MgO, what will be there, students? Finally, in this product, what will be there? Magnesium oxide plus, and how much excess reagent is there here? Oxygen is excess reagent kada. How much given? 30 grams given. This is 20 grams. How much left over, students? The mass of oxygen left over, how much, students? Is equal to 30 minus 20. Clear? So the mass of oxygen left over is equal to 30 minus 20 is equal to 10 grams. That means along with this product, Nana, magnesium oxide, okay, the magnesium oxide, 50 grams of magnesium oxide plus and this oxygen, okay, which is excess there, this 10 grams of oxygen also present along with the product. Are you clear this one? Because it is excess, it is not consumed in the reaction, does not react with the magnesium. Are you following? So this is the excess reagent. So what is the composition of the product means what you have to take, students? What you have to tell, the composition of the residual mixture contains 10 grams of oxygen. This one 10 grams of oxygen Okay, this one oxygen, Nana. 10 grams of oxygen, and one more is 50 grams of magnesium oxide. So finally what we can say, students, 50 grams of magnesium oxide. So here you have to write finally the composition, the composition, the composition of residual mixture is equal to 10 grams of water plus 50 grams of which one, students? 50 grams of MgO. Clear, Nana? So like this you have to find it, students. So here you have to find first according to the first equation, right? Magnesium combined with oxygen produces magnesium oxide, MgO. Next, Mg, how much weight you write? 2 moles means 2 into 24, O2 32 grams, 80 grams I wrote. So I am going to calculate to find which one is limiting and excess reagent, means you have to find only these two reactants. You should not think about the product, students. Only these two you have to take. Now see, I am taking this one 2 into 24 grams, 24 grams of this one, which one, students? Magnesium kada, this one. It is 32 grams of oxygen is required. 30 grams of the magnesium is asking question, 30 grams of magnesium, and oxygen weight also given. I am going to checking this one oxygen, so that's why I am taking as X. Okay, now in the second case what I am calculating, magnesium I am going to calculate, that's why oxygen 30 grams I am taking in the second case. In the case one, what I done here, in the first case 30 grams of magnesium taking, oxygen mass I am calculating. In the second case, oxygen mass 30 grams I am taking, I am going to find the magnesium. Clear, students? This is about the limiting and excess reagent. Now see, students, this second problem. See, in another second problem, 0.5 grams of magnesium is burnt in a closed vessel which contains 0.25 grams of oxygen. Okay, now so magnesium is burnt in a closed vessel which contains oxygen. So here what is the reaction, students? What is the reaction? Magnesium combined with O2, same reaction, 2MgO. Okay, now magnesium balance this equation, students, 2 moles of Mg. Now equation is balanced. 2 mg means 48 grams, O2 means 32 grams, 2 MgO, magnesium 24, oxygen is 16, total 40, here 2 moles, that's a 2 into 40, 80 grams of magnesium oxide. So 48 grams of magnesium combined with 32 grams of oxygen produces 80 grams of magnesium oxide, students. Okay, now I am going to calculate magnesium and oxygen, which is in this, so in these two reactants only, in these two reactants only, one is excess, another one is limiting reagent will be there, students. Magnesium, it may be excess or limiting, it may be excess or limiting, we don't know, but in the reactant side only limiting and excess reagent will be there. Okay, now one is limiting, another one is excess. Which one is excess, which one is limiting, we don't know, we have to find it. Now that's why what I am doing, magnesium what given weight I am taking here. Okay, oxygen weight I am going to calculate. Are you following? Afterwards I have to check that value with the given value. Then if the given value is less, that is the limiting reagent. If the given value is more than the calculated value, then that is the which excess reagent. Okay, now I'm going to calculate. First, magnesium how much given? 0.5 grams given. So oxygen I'm going to calculate. Are you following? This two relation I'm taking, students. This two relation I'm taking. So I'm going to find the x value. So how much, students? X into 48 is equal to 32 into 0.5. Then x is equal to 32 into 0.5 by 48. Now calculate, students. 32 into 0.5 divided by 48. How much, students? 0.333. How much, Nana? 0.333. This which one, students? Oxygen kada. grams of O2 is required to combine with 0.5 grams of magnesium, 0.333. Now you check students, oxygen how much given, 0.25 given. Now you compare these two values, which one given value is less or more when compared to this value is less. Correct, this is 0.333, this is 0.25. That means given value is less. Given value is less, then oxygen is the limiting reagent. Are you clear this one? Okay, Nama. So that is the limiting reagent, students. Okay, so which one is the limiting reagent, Nana? Which one is the limiting reagent? Oxygen is the limiting reagent. Clear this one? So O2 is the limiting reagent. O2 is the limiting reagent. Clear this, students? Now see students, O2 is the limiting reagent. Are you understood this one? So we here 0.333 grams of O2 is formed. So you have to check this value with the given value. If the given value is small, that is the that is the limiting reagent. If the given value is more than the calculated value, that is the excess reagent, students. Understood that? Understood, Amma? So O2 is the limiting reagent. Now which one is the excess reagent, students? Now which one is excess reagent? How to find it? Excess reagent. Now here in magnesium and oxygen is limiting reagent, means magnesium is excess reagent. Now we have to check it is excess, it is correct or not. So what I am doing in the second case, students, oxygen weight I am taking. Here what given, that weight I am taking, I am going to calculate the magnesium weight. Now that magnesium weight what I calculated, that value you have to compare with the given value of magnesium. Are you clear this one? See here, so this one O2 is the limiting reagent. Now here what I am taking, Nana, this is the case 1, students. In case 1 we calculated. Now in the case of second case, what I am taking, this one as it is I am taking 48 grams of magnesium combined with 32 grams of O2, students. Okay, 32 grams of O2. Now in the question what I am taking, oxygen weight I am taking. Oxygen is 0.25 grams. So here I am taking as 0.25 grams of oxygen can combined with how many grams of magnesium I am going to calculate. Now x into 32 is equal to 0.25 into 48. Then x is equal to how much, students? 0.25 into 48 by 32. Then calculate this one, 0.25 into 48 divided by 32. How much, Nana? This value 0.375. Understood, Amma? 0.375. Now see, students, this is 0.375 grams of which one magnesium is formed. Now this value you have to check with the given value 0.375, but given value how much? 0.5 grams of magnesium. So this is how much given? 0.5 grams of magnesium given. Okay, now you check these two values, students. Two values which given value is more when compared to this one. Yes, given value is more, 0.5. This is 0.3. So given value only you have to see, students. Given value is more, then magnesium is the excess reagent. Are you clear? So this is the excess reagent, students. Okay, now question is what, students? First question, what is the limiting reagent? What is the limiting reagent? Which is the limiting reagent? First bit, first question. O2 is the limiting reagent. And what is the second question, students? Which reactant is left in excess? Which reactant is left in excess? So which is excess reagent, students? Magnesium is excess reagent. Correct? 0.5 grams we got. But actually how much we calculated value magnesium? 0.375. This is which one, students? This is the given value. So how much is excess? How much reactant is left in excess, students? How much excess this one? How to find it? 0.5 minus 0.375. You have to calculate, then you will get the value, students. See here, 0.5 minus 0.375. Understood? How much, Nana? 0.125 grams. So this is the magnesium, 0.125 grams of magnesium. This is the excess reagent. How much excess? How much left over? This is the mass of magnesium mass of magnesium left over. Clear? How much, Nana? 0.125 grams of magnesium. Okay. So this is about the limiting and excess reagent in weight calculation or mass calculation, students. I hope you like this video. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, Nana.